Okay, so now we can actually do what I wanted to do in the previous tutorial, and that was to model out this back part before I got all caught up in the topology optimizations. So we're just going to control click, bring in a vert here, and just roughly line it up to where this edge should exist. And I'm just going to hide everything else. Just going to extrude this up, and we're kind of going to use the same logic as earlier, where we want to overshoot on both sides so that we can bevel this in later, and then it will start to sit flush. Extrude this out, line that up. And then with these top two vertices, we're just going to use this edge here to know how far back we need to push them. So about there. Then with these, oops, I didn't seem to have selected both of them. Then with the middle vertices, we're going to reference the bottom vert and pull it out to the edge of the reference. And then we can fill in that face, flip the normals. We'll add in a loop and we'll just pull it out a little bit on the normal just to give it some curvature. And we'll go ahead and we'll bevel the middle. And we can space and relax that just to make it a little bit more exact. And shade smooth. Cool. So let's go ahead and let's just bring the helmet back in. So our bevel is here and it consists of 5 verts, so that means we need 4 segments. So let's bevel it out. So okay, just 4 segments, and you'll notice the upper rightmost vertice, I'm just having that almost connect with that. It hasn't quite merged, so I'll just merge it center to get rid of it. And then you'll notice here, this isn't a completely straight line. It sort of tapers down and off a bit. So we'll set our cursor to this middle point. Select those edges. Use the 3D cursor as the pivot point. Get the shear transform. Press Y to move along the Y-axis, or shear along the Y, I suppose. And just move that down until it lines up a bit more. Then with that, we'll just select this middle edge, cursor to selected, and then select the outside vertices, E to extrude, and we'll just scale this out until it roughly fits. So I'd say around there looks good. And then we know how far to bring this back, because if we deselect and reselect this vertice to make it the active edge, and then use our snapping to bring it back to this vertice here. That'll bring it back just the perfect length that we need. And then with that out of the way, we can start to connect all of these pieces together. Till about there. And we'll just use this vertice on the left to use the knife tool to cut across. And then we've got 5 additional vertices that we need to link up. So we can merge that at last. Sorry, that one there. And that one there. Cool. And then we need 2 more loops through the middle here. And I'll just cut these ones through. And then we can just go ahead and, oops, doesn't look like those are connected, merge it last. And then we just go ahead and crease these edges. So that when we look at our subdivision surface, it looks all nice and smooth. So before we do anything, we're going to go ahead and select all these faces that we've just created, duplicate it, select it, remove by selection, or separate by selection, I should say, sorry. And we'll call this shrink_part, or plate more so. We'll just change the viewport type to be bounds. And then we'll go ahead and move that into our shrink wraps. In doing that, we're going to go ahead, select all of the faces again, make a new vertex group, assign it, and we'll call this one plate. Cool. So it'll become clear as to why we're doing that in a second. And actually, while I'm thinking of it, we'll apply that shrink wrap. So target should be the shrink plate and plate. So we've got these two circular bits on the back here, and you're probably thinking, well, let's just model them as floaters on top of the rest of the topology and make life easier. We're not going to be doing that because the idea of these tutorials is to teach you guys about topology and hard surface modeling. Is this excessive? 100%. But is it a good exercise in handling more complicated topology and meshes? 100%. So we're going to do it, and I promise you it's not going to be that bad. So I just went ahead and dissolved those two edges because we're not going to need them for what we're about to do. And I'm just going to bring this edge down a bit just to give a bit of a buffer zone for where we're going to place the details. I've completely lost my words apparently. I'm just going to space those out. And I'm just going to apply that just so I can see the shrink wrap in effect. So just trying to estimate roughly and click in the center of these details to move our 3D cursor. After doing that, I'm going to delete these faces and let's bring in a circle and change its vertices to 22. Let's scale this down. And we can just adjust it because I didn't get it perfectly centered. Something like that. And what we're going to do is we're going to join this together. Select the circle mesh, and we're just going to apply it to the plate vertex group, and you'll see that will snap it out to match the curvature. It's sort of screwed up the shape here a bit, so we're just going to use the circle operation in our loop tools menu just to make sure it didn't deform it. And then we can just go ahead and just adjust it a bit, and that should be better. Cool, so let's start to integrate this in with the rest of the mesh so we can make this one cohesive thing. What I'm going to do here is just go ahead and hide this face. I'm going to cut a loop in here, and we're purposefully going to make that an n-gon. And I'll show you why we can get away with this. Because if we go ahead and put our subdivision on, let's put the shrink wrap above so the shading's alright. You can see, yes, we've got some pinching in here, but it's located in a crevice. So, you know, once we add our grunge, our dirt, and all these things, it's not going to be immensely noticeable. It's also at the back of the helmet, so, you know, once we model in the faceplate and get everything else at the front all sorted, it's really going to be anything but a focal point, and it's just not going to show through. So, look, if you really want, you can, by all means, go ahead, add a loop in. I just don't think we need any more topology at the front. I think we've sort of hit enough for the time being. So you can add that loop. I'm not going to, but the option is there. It's ultimately your model. I'm just going to add in 3 edge loops to the bottom here. To get that. And these edge loops I can justify because we are going to need to eventually model the bottom part of the helmet here. And these will help add to that topology for the circular part at the bottom. And I might just go ahead and, oops, that's not part of the helmet that we're working with. Do that. And so we've got 5 more edges that we need, so we'll just cut in 5 onto that. And I just want to check. Cool, that's all become a part of our vertex weights. Cool, so look, it wasn't that bad, was it? We've cut these circles in, it's on a curved surface, and it all looks pretty good. Even with the subdivision surface, it's all looking pretty nice and smooth. You can see like just it looks a bit weird because we've added in some of the new bits of topology, but we can always smooth that out at the end. It's not going to be a big problem. So speaking of, we probably don't really need the shrink wrap on at the moment, so we can just apply that. And these bits in the middle here aren't clipping properly. And I don't want to select all of those, I just want these. Slide those into the middle to make sure the mesh is all connected at the center. Cool. So we can just go ahead and just select all of these edges here. Yeah, and you can sort of see that jaggedness that's appearing there. So let's just go ahead, space, and we'll just relax. And that's taken all the jaggedness out, so that's nice. Now let's start to model out this detail here. So we can just extrude, actually before we extrude that, sorry, my bad. Let's grab the normal for these, add it as a new transform, and we'll go scale Z0. Oops. And let's just go loop tools, circle. Just to make sure it is properly circular, I should say. I'm not going to do it on the first part because I don't want to deform the mesh. And then with that, sorry, I just deleted that. That's right, that should be fine. Then we just want to scale this into size, and it sort of comes and skews a little bit more to the right here. So I don't even think this, like, I don't know if on the actual model, if it's a perfect circle. Something tells me it's not. And actually, I think, let's go to the Y instead. I think that makes a little bit more sense as opposed to scaling out to the local Z. And then we can just use a shear and match that up, and then we could actually use that normal instead. That makes more sense. There we go, that's nicer. So we can match that shape up, and then what we're going to do, because there's a whole lot of like intricately modeled detail here, let's fill in a face, and we'll just use the insert tool to roughly match up this detail. So we've got that. We've got this. Yeah, see, I don't think theirs is a perfect circle somehow. Oh no, something screwed up on ours. Let's go circle. Mine's not a perfect circle, never mind. Scale that out a little bit. Alright, now let's do the insert. There we go. Never mind, I won't call the reference material not proper. It's definitely me doing something wrong. Okay, so got that. And then it's kind of hard to see what's going on in the middle here, so I'm just going to sort of approximate the size of that middle circle. And then there's like a circle there. There seems to be like a divot in the middle here. It sort of gets pushed in, and then like another, like, I don't know, a ring that sort of gets pulled out there. Okay, so we've got so much topology there. Let's use the normal, and let's extrude this in a bit. Scale it in a bit as well. Nice. Let's select everything until that point, and we can pull this in. I'm just eyeballing all this, by the way. I've got no clear defined way of how this should be done. For this, I think this needs to be pushed in, so I might just add another loop into the middle of it. And that will let me pull that in there. And then I think that sort of happens again. I'm just going to turn the mirror off. So that middle bit, and then I think this ring, so I'm just going to add these two in. I think this gets pulled in. I think you sort of get like a standing part on the outside there. And then just before it's pulled in a final time, I think this bit is raised. Like so. And then I think the middle is also raised here. So I think it sort of does. Sort of does something like that. I've got no idea, frankly. I can't really see. I'm just taking a guess at how I think this might look. It's also not an amazingly important detail. Do we need to dedicate this many vertices to this area? Definitely not. Am I going to do it anyway? Yep. Cool. And it looks pretty nice. So I think that pays off. And in all honesty, the support loop around here doesn't look too bad. Well, the support loop doesn't technically exist, but the bevel into this area looks pretty nice. There's just a few problems that I don't like. One's here, and the other one's here. And I don't like those because that's where the poles are being created. But I think there's a pretty good way to fix this. So what we're going to do is we're going to actually cut in a loop into this. Use GGEF and slide it in. It's going to make this pretty tight. And I'm sort of just looking for it to sit halfway between those edges there. I'm actually going to take the crease off of that area. And I think what we can probably get away with is doing another one of these n-gons up here. So cut that in, and then cut this. So it's fine to have a pole there because that's not natural, that's not like a creased edge or anything. So that will work fine. Just go ahead and space. Maybe I won't space it out. I'll just space it out between these ones. Yep. And then for this, I want to change this up a bit. So let's have this guy here. So have this one go there. And then just trying to think, there's a reason that this isn't working. I think it's actually because we don't need that edge, that's why it's not working. Cool. We can space those out, and don't worry, I haven't missed that n-gon. I have seen that. Now we can just do that. Space that out. Cool, there you go. So, you're going to win an award for the prettiest looking topology? Probably not. But it works. And you've managed to model a piece that probably looked pretty terrifying to start out with, especially since I said, you know, we're going to model circular assets onto a curved surface. You know, that's never fun, but it's panned out pretty well here. So you can see that it is possible, and we've got really nice shading around here as well. It all comes together very, very nicely. So you should be proud of that. That's very impressive. Okay, so before we wrap this up, I want to also do something that I wanted to do in the previous tutorial, which was connect these two meshes together. But before we get on to doing that, let's start to build out the back part of the helmet and the bottom part of it at the same time. So I'm just going to select all of these edges, vertices, get this edge, and I'm just going to bring it down just so it roughly matches this line here. I'm just going to go Shift-C to bring our 3D cursor back to the center point of the helmet. Well, roughly the center point, it's not exact. We're going to use our 3D cursor as the pivot point, and we're going to scale on everything but the Z-axes, so using Shift and Z. Just going to scale this in. I'm just going to hide everything that's not this, and I'm just going to scale this on the Z. And what do I want to do? Let's change our 3D cursor to be the center point there, and let's rotate. No, actually, I don't like that. Let's make this easier on my eyes. Let's space this out. Use this as the center point. And we can rotate with that instead. I think that should yield a bit nicer of a result. And let's just do some manual cleanup here just to bring these into line. And now if this doesn't line up perfectly with the back, it just means that we don't have the correct curvature. So I think these are okay. I think these probably just need to be pulled out on the X. That should be about there. It's a bit jagged, so I'm just going to relax it. Cool. Alright, that's looking pretty good. And so now that we've got those, we can duplicate these ones and do the same thing. We can just bring these down. Actually, let's bring it down and snap it to... Sorry, bring it down. We'll deselect and reselect the leftmost one, and then snap the vertices there so that we're using the active. And then we can probably snap it again in on the Y, and you'll notice that matches the curvature pretty damn well. Let's go merge vertices at last. Select everything, and we'll just do a relax just so it's not so jagged at the corner where we've merged the two together. And I'm just going to do a edge slide here to bring that back into line. Cool, okay. So this part's a little bit tricky because we've got a bit of a bevel at the back here, but then it also needs to line up flush with this part. So we need to have something that bevels but then also tapers back into the rest of this design. So it's going to get a little bit tricky here, but I think there's a fairly valid and easy means of doing this. So to lay the foundations for all the work we're about to do, let's just duplicate this and snap it down to this vertice. And we can just drag that in. Pretty much just tried to line it up with the outline again, best I could. And we'll see if that's an accurate point to place it. I don't think it is, just based on how that's coming out, and then this is curving. I'm just going to adjust it to be... I don't know, it might actually be okay. It might be more where this is situated, so I might pull that up. To be more there, maybe, and then just actually scale this down. Maybe I won't scale it down to 0 on the Z. That's almost okay. I'm just going to GGEF. There we go. I think that looks nice. Alright. So, now time for the tricky part of getting all this to line up nicely. So, we know that all the vertices here and all the vertices here are the same amount, so you could technically go and do a bridge edge loops and it's going to work, right? It's probably going to be a bit wonky along there, so actually what I'm thinking is let's just go ahead and space these out. Whoa, maybe just relax it. So yeah, that bridge operation still isn't perfect, but it's better than what it was before, so we can roll with that. So yeah, let's go ahead and do that bridge, actually. So we've got part of what we need, and we know that this lines up properly, right? So we've got a little bit of the process already sorted, but not all of it yet. And I'm also just noticing that this sort of isn't really sitting flush with itself, so I'm just going to do an edge slide. Just eyeball that. I think that looks okay. Alright, so what we're going to do is I'm going to add in a loop. And I'm just going to line it up with that one over there. Because we know that we need some sort of bevel in here, right? Because we can see it push in the back of the helmet here. So we know that these loops are going to come in to this section as well, right? So what I'm thinking, let's go Shift-C, so we can take our cursor back to the center. And let's not select these last 2 points here. Select all these. Set our 3D cursor as the pivot point, and let's go Scale Shift-Z. So we scale on everything but the Z-axis. And actually we should use the reference image. So sorry, Scale Shift-Z. Let's just bring these in. Just all about there, okay? So now if we look at it, we have a bit of a taper, but it's pretty aggressive. So let's just select all of them. Just go relax. And so now it sort of resolves a little bit smoother, right? May not be perfect, but you know, it's part of the way there. Then what we're going to want to do is we want to do a bevel. So we've got 3 vertices that we need to connect to the rest of this, right? So we can do a bevel on this with 2 segments. Drag this out. Nice, and I'm going to do the same thing. So with our 3D cursor still as the pivot point, just going to deselect just that one, no, sorry, do it to there. And I'm just going to accentuate this just a little bit more, so I'm just going to scale in with Shift-Z, so we're scaling on every axis but the Z-axis. And then we'll just relax. So this still isn't perfectly lined up, so we can probably pull some things out, or we might actually just do an edge slide so we don't mess up the rest of the topology. That's the wrong 2 edges to select. So we've got that. So you can see it's not too bad, like it's almost there. It's just not quite perfect, but that's okay. So in favour of trying to not break everything we've got here, and just because this doesn't line perfectly, what we're going to do is going to go ahead and dissolve. Oops. Dissolve that edge there. And this will make sense in a second as to why we're doing this. I'm going to grab these faces and just try to help with the taper that's going on here. We're just going to move these in on the X. Just to somewhere around there. By no means is that perfect. We'll just add a loop into the middle there. Actually, no, instead of doing a loop in the middle, we'll select these and we'll just do an edge slide. Back to there, and just Control plus and do by distance. And remove those vertices there. And to make this less apparent, let's just go Shift A -1. And I know this is going to make a triangle, but I think this will just make a little bit more sense. In the grand scheme of how this is being handled, and I don't think taking out one vert there is going to hurt this too much. I think that should still look okay. Cool. So that works nice and flush, and you can see now we're getting that strange sort of tapering from this bevel to a more flat part out on the side, and back into the nice bevel shape that we have at the back there. And so one thing I am going to do, because I think this is just a bit too sharp, I'm going to remove the crease, but that sort of removes all the edge from it, so I'm just going to add a crease of 0.33. I think that just adds in a nice profile to it again. Cool, so with that done, we can just go ahead and add in the rest of the details that we need here. Well, sorry, not details, just topology, I should say. Because we're going to want to connect all this together. And so what we're going to do is, let's just slide this edge down. We can join these together. And sorry, I should have explained. We dissolved this edge before because we pushed all these bottom faces in, and I'll just show you here. If we tried to push all of these faces in with that there, you would get you wouldn't have a completely flat face anymore. So if we crease this to make it more obvious. It's kind of hard to see there. You can just see a little bit of a crease. So if we didn't dissolve it before making that adjustment, it would have made a surface that isn't perfectly flat, and that's not what we want. So anyway, sorry, just a tangent there. Let's bring this one down further. I know it's probably a bit outrageous, but it's okay, and we'll bring that down to there. We'll just keep on adding to this massive bloody n-gon that we've created. 1, 2, 3, 4. We'll just do 4 so we don't have to do it manually. And then we'll just do the same up here. Cool. And let's just start to fill in all these faces. Yeah, look, we don't need to even bother about filling in that one, and I'll show you why, because what we're going to do is, with this outer edge, we're just going to do a loop slide, crush it into the middle, Control plus, and merge vertices by distance. Just crease that edge up again. Now we have successfully destroyed all of our creasing work. No. We've successfully made this a single and comprehensive mesh. I mean, like, apart from this, but I don't want to punish you with trying to make that a part of the mesh. That's just not fun, and that's not a valuable exercise to do. So yeah, there we go. We've integrated this all rather nicely. It's just this doesn't look all too flash hot, so what I'm going to do is I'm just going to add in a loop around here, and we can just use an edge slide to sort of crush that in a bit. Just bring it into size. It's still not going to be perfect even once we do that, because it's just a bit of a nasty pole. Yeah, even dissolving that's not really going to fix it. but I don't think it's too bad in the grand scheme of things. We could probably help it a little bit more if we... I'm just going to actually delete this because it's not serving any purpose at the moment, and we can build that later on. I'm just going to do an edge slide here. Just sort of push that out to the edge more. Yeah, so look, that's not a perfect solution, but it just makes that edge look a little bit nicer. Just adding a loop in through here and sort of just pulling that across a bit more. It's not going to be perfectly even along here anymore either, but we can just space these out. Yeah, look, that's going to work well enough. It's a bit of a strange area in how it, you know, sort of tapers from this and back into this. So look, it's all a little bit strange, and I might actually just space these away from that edge, just so we're not creasing it up. That's much better. Look, it's still not a perfect resolution, but I think it looks nicer than what we had. I just wonder, what if I change this to 0.55? Would it look... Yeah, okay, so we can do 0.55 there. Look, we might just be able to do it for the entire length of this. I know I wanted to do it because it just made it sort of look a bit too sharp, but I think doing that along with those adjustments will just make it look a little bit nicer. Yes, it is probably a bit sharper than I'd like, but I think for the grand scheme of things, that's a much nicer way of resolving things. So, yes. But yeah, now look, everything's built out nicely, and we're one step closer to being able to build out the front with the iconic faceplate and have the model completely done.